Hi everyone, lesson 114, graphing square root functions. When we are graphing square root functions, all of our functions are going to have a radical in it. So a square root function is a function that contains a square root of a variable. So in this example, on the left-hand side, you can see the picture of a table that's filled out, and then you have a graph next to it. That is the parent function of a square root function. So y equals the square root of x. Because you're dealing with radicals, and if you want your graph to only use integers or whole numbers, your x value should be a perfect square. So that's why they use 0, 1, 4, 9, 16. Use the smallest perfect squares, and that makes your numbers easy to work with, easier to graph. So let's take a look at this first example. Y equals 3 times square root of x plus 1. And here I put the numbers in the table for you. So if we put 0 in for x, square root of 0 is 0. 0 times 3 is 0. 0 plus 1 is 1. Put a 1 in. Square root of 3 times the square root of 1 is 3. The square root of 1 is 1. 3 plus 1 is 4. Put 4 in for x. The square root of 4 is 2. 2 times 3 is 6. 6 plus 1 is 7. And then the square root of 9 is 3. 3 times 3 is 9. 9 plus 1 is 10. So now that we have our table completed, now we can just plot them on our coordinate plane here. Again, these are all counting by ones, so just to save some time, I'm not going to label them, but you can see that we're counting by ones. So I'm going to put my first point at 0, 1. So 0, 1 would be right here. Then I have 1, 4. There's 1. 4 would be right up here. 4, 7. 4, 7 would be here. And then we have 9, 10. 10 would be all the way up here. So you can see I have a bend in my graph. So all I need to do is now just draw it. So I start here, follow the points. So you can see I have a curve here. This would be a square root function. Let's take a look at another example. This time the numbers are very similar to the last one. The only difference now is I have a number added to x inside the radical symbol. We're going to do the same thing, but you'll notice that my x values that I'm plugging in is not perfect squares. And the reason why they're not perfect squares is because I'm adding a number inside there. So when I do the computation there, so when I do the adding, it does become a perfect square. Then I can find the square root of that. If I put a negative 1 in for x, negative 1 plus 1 is 0. The absolute value, or the square root of 0 is 0. 0 times 3 is 0. Put a 0 in for x. 0 plus 1 is 1. Square root of 1 is 1. 1 times 3 is 3. Put a 3 in. 3 plus 1 is 4. Square root of 4 is 2. 2 times 3 is 6. Put an 8 in for x. 8 plus 1 is 9. Square root of 9 is 3. 3 times 3 is 9. So now I have my table created. And come down to my coordinate plane again. Each line is counted by ones, so I'll plot them. So x is a negative 1, y is a 0, so it's here. 0, 3, so 0 up to 3. 3, 6. There's 3, 6, and then 8, 9. 9 would be up here. So you can see that I have my curve going. So I start here, follow the dots. Here's my curve for this function. Example 2a, determine the domain of a square root function. Now earlier in the year, we worked at finding the domain and range of functions, of linear functions, of quadratic functions. These are the same thing. So the domain is always referring to what are all the possible x values that will work for this function. So you can see in letter A, they have a sample done for you. It says determine the domain of y equals the square root of x minus 4. To solve these, all you need to do is take the radicand, so whatever's in the radical symbol, make that greater than or equal to 0, because you can't find the square root of a negative number. So it's got to be greater than or equal to 0. And when you do that, solve for x. So they added 4 to both sides, and they had x is greater than or equal to 4. That would be your domain. So let's look at an example down here. Determine the domain of y equals square root of x plus 9. So I take my radicand, which is x plus 9, write that down. This has to be greater than or equal to 0. Now all I need to do is just solve for x. So I'm going to subtract 9 on both sides. And that gives me an answer of x is greater than or equal to a negative 9. Any value of x that's greater than or equal to negative 9 will work. Because if I put a negative 9 in, negative 9 plus 9 is 0, square root of 0 is 0. So a negative 9 is the smallest number I can actually put into the function. Example 2b, the function is a little more complex. You can see there's a lot more numbers. There's more things to do inside the radical symbol. But again, the only part that you have to focus in on is what's in the radical symbol, the radicand. And you just make that greater than or equal to 0. So if we look at the example on the bottom, it says find the domain of y equals 2 times the square root of x divided by 4 minus 9 plus 4. So I only need to look at this part right here. So if I take x divided by 4 minus 9, this has to be greater than or equal to 0. So now I need to move everything away from the x. So the first step is to add 9 to both sides. So now I have x divided by 4 is greater than or equal to 9. And then the last step is to multiply by 4 to get the x by itself. Whatever I do on one side, I do on the other. So the domain is x has to be greater than or equal to 36. So if I were to put 36 back into the original equation, 36 divided by 4 is 9. 9 minus 9 is 0. Square root of 0 is 0. 0 times 2 is 0. 0 plus 4 is 4. Therefore, this works. For our answer, the domain would be x has to be greater than or equal to 36. You may try these two yourself. Examples 2c. Example 3a, translate the square root functions. Remember, to translate a function means to move it a certain way, whether you're moving it up, you're moving it down, to the right, or to the left. Today we're going to be looking at translating the square root function. So here in the example, the top picture, you see an example of a square root function. You have the parent function graphed, y equals the square root of x. That's this graph right here. And you can see that it is being translated, so it's going up here to this one, the black one. Now, how did it go from the red one to the black one? Well, according to the function here, it says it's plus 3. So it went 3 units up from the start. So if you count 3 up, here's 1, 2, 3. So it went up 3. Everything else stays the same. And you can see the table. If I put a 0 in, the parent function is 0. But then if I add 3, I get 3. So I'm just really adding 3 to each of these coordinates of the parent function. And it gives you your new y values. So now you can have vertical translation, which means if you look in the lower box here, the square root of you have a plus c on the outside. If it's plus c on the outside, it goes up. If it's minus c on the outside, then it's going down. The horizontal translation is telling you now the c is on the inside of the radical symbol. So here you have x, square root of x minus c, and that is the basic form. So if you ever see an x plus c in there, it really means x plus a negative c, because you need to put it back into its negative form, or you keep it as like the square root of x minus or plus c is the same as the square root of x minus a negative c. Those two are the same thing. Okay, so just keep that in mind. And so whatever c is, that tells you which direction you need to go. So if it's plus c, that means you got to go to the left. If it's a minus c, then you go to the right. Let's take a look at an example here. Describe the transformation applied to the parent function to the form y equals the square root of x plus 2. Since I have a plus 2, this is my c, and it's on the outside. So that means I know my function moves up 2. Okay, because that's what that plus 2 on the outside means. The second one, describe the transformation applied to the parent function to the form y equals the square root of x minus 4. So now the 4 is on the inside. I still have it in this form, x minus c. So whatever c is, that's going to tell me where I need to go. So the function moves 4 to the right. Another way of looking at it would be, what's going to make this square root of 0? Well, this x right here would have to be a positive 4. So that would mean you have to move it 4 to the right. That's just another way of thinking about it. Example 3c, I'm going to have you try these two yourself for extra practice. Example 4a, reflecting a square root function. So now here you're going to have negatives involved. So if you look at the top box, if the negative is on the outside, the reflection, your graph is going to reflect across the x-axis. So if this is the x-axis, it's going to go from here down here, or it might go from here up here. Okay. On the other one, here you have the negative on the inside. And so if the negative's on the inside of the x, that means that it crosses the y-axis. So if this is my y-axis, if my graph is going here, it's got to reflect to the other side over the y-axis. So if you look at an example here, letter A, describe the transformation applied to the parent function to form y equals negative square root of x. You can see the parent function right here. And now if you put a negative on the outside, everything that comes out of the radical is positive. Multiplied by a negative, you reflect it over the x-axis. So that's why your new function is coming down here. Okay. So now your y values are all going to be negative. Let's take a look at another example. It says describe the transformation applied to the parent function to form each of the given functions. So here I have the function of x equals the square root of a negative x. Because it's on the inside, it's got to cross the y-axis. So it reflects across the y-axis. And it doesn't move anywhere else, so it just reflects across the y-axis. The second one, the function of x equals the square root of negative x minus 5. To help you with this, I would rewrite this as the square roots of a negative We're going to factor out a -1, so that makes this x plus 5. Okay, because we want this to look like the parent function, the square root of x. Okay, so now we know it reflects. It's on the inside of the radical, so it does reflect. It reflects across the y-axis. And because I have now it's x plus 5, we need to do the opposites. What's going to make this square root of 0 when x is a -5? So that means I have to go, and it moves to the left 5. So that's how it would move from the parent function to the new function. Take a look at one more, and then you can do the next one yourself. Describe the transformation applied to the parent function to form each of the given functions. So the function of x equals the negative square root of x plus 3. The negative's on the outside, so it reflects across the x-axis. And what's going to make this negative, or what's going to make this 0 when x equals a -3. And so it moves 3 to the left. You may try the next one yourself for extra practice. Now let's go through an application. The distance d in kilometers that Melissa can see on a clear day to the horizon from a height of h meters is approximately d equals the square root of 15h. Find the distance she can see from a height of 2,160 meters. So h is the height. If I take my d equals the square root of 15 times my height, which is 2,160. So if I were to multiply those in there, you would get an answer of 324,000. Square root of 324,000, or 32,400. And then the square root of 32,400 will give you an answer of 180. 180 meters is the distance you can see from the height of 2,160 meters. And this should be kilometers because the label said in kilometers. You might try the second application one yourself for extra practice. Your assignment for next time will be lesson 114, numbers 5 through 9, 12 and 13, 21 to 22, and 25.